Sir, good morning, Professor.
Mic mute कर दीजिए.
Okay. Sir, good morning, sir.
Professor, good morning, Professor. Has the invited speaker joined?
Okay. Praveen Kumar, sir. Praveen. Yes, sir. Yes.
I think Dr. Praveen Kumar is set to join. Good morning, Professor. Dr. Praveen Kumar. Sir. Balamurli, sir, are you able to hear me?
Yes, sir. Yes, sir. Yes, sir.
Good morning, Professor.
Sir, good morning, sir. Very good morning, sir.
Welcome, sir. Welcome.
Thank you, sir. Thank you so much, sir.
So our invited speaker has come. Dr. Balamurli, shall we start?
Yes, sir. Yes, sir. Yes, sir. Please start, sir.
Yes, sir. So, a very good morning to all the delegates, respected invited speaker, Dr. Praveen Kumar, Dean, School of Commerce and Management, Bharat Institute of Higher Education and Research, Chennai, India. Let me shortly introduce Dr. Praveen Kumar. He had his doctorate in management and literature, English literature. He is an editorial board member of 15 national and international journals, and he has authored many books. Some of his books include the topics on internal marketing in IT industry, published by a German publisher, prospects of gamification on user engagement from Germany, retail management, business communication, operations management, and he is serving as a reviewer and an editorial board member in various reputed journals, and he has published over 70 empirical research papers in Scopus, Index, and international journals. He has an academic experience of over 20 years in reputed organizations. He is a gold medalist for general proficiency in English literature from Loyola College, Chennai. He has a distinction from JDV Pune. He is a certified accredited CBT practitioner, and he has got fellowship in FSIESRP. And he is also a visiting faculty in Commonwealth University London, Help University Malaysia, Ural Federal University Russia, MPRH Institute Iran, and Yuan Ki University Iran, Loyola Institute of Business Administration and Informatics, and he is a recipient of several awards, including Rashtriya Vidya Saraswati Puraskar, Star of Asia by IIEM, and so on. And he is a member of advisory board in various councils. So he has been guiding various academic projects, and he is a top contributor and very active contributor for NAC and NBA accreditation in Bharat Institute of Higher Education and Research. I welcome you, sir, to this international conference on recent advances in science, technology, engineering, management, and social science, organized by New Rains and in association with Addis Ababa Science and Technology University, Ethiopia, and KARPAGAVINAYAGA College of Engineering and Technology, India. Welcome, sir.
Thank you, sir. Thank you.
Now,
sir.
session is yours, sir.
Thank you so much, sir. Good morning to all the learned professors. I am super thrilled to be in this conference. I'm very thankful to Dr. Kamaraj. He's a very vibrant and erudite professor. So anything that he organizes will be of international standards. So my sincere appreciations to Dr. Kamaraj and his entire team of various organizers from different countries. So being a multidisciplinary forum, though I come from a management background, but this is a multidisciplinary forum. People from different backgrounds have come. So I'm keeping my keynote address very common, so that everyone is able to relate. Just give me 1 minute to share my screen.
Yes, sir. Yes, sir. Are you able to share, sir?
I'm unable to share, sir.
Balaji?
Yes, sir.
Allow the invited speaker to share his presentation.
Okay, sir.
Yes, sir. Yes, sir. I got the permission, sir.
Yeah, yes, sir. It's coming, sir. Yes, we are able to see the screen, sir.
Thank you so much, sir. Thank you so much, sir. So this is a common presentation, as I've told you, though it is called Business Biology. Look at this. Harvard University is going to use an AI professor from next semester. Next semester is just 2 months away. So look at our competitors. Earlier, a fellow teacher would be our competitor, but now with the advent of artificial intelligence, are these humanoids going to take away our jobs? Is a very big question that is posed before us. And when Harvard is using, we need to think. It is because these humanoids can understand natural language and answer any question. You know, the quality of students and staff at Harvard. So if Harvard is ready to experiment these humanoids, these robots, I think the time for artificial intelligence has come and is ripe. So in this context, these forums, intellectual forums, these academic knowledge sessions are very imperative. That is why our appreciation to the organizers for creating such global forums for us to match the humanoids that are going to come. We have always traversed in different waves. In wave one, it started at 1785. It was the era of cotton, iron, water, power. These were all put to use around Industrial Revolution. That is when Industrial Revolution started. Wave 2, we migrated to railway, steam, and mechanization. That is when railways were introduced, transportation changed for the better. Wave 3 lasted for 50 years, and that was the era of steel, heavy engineering, and electricity. Wave 4, when many of us were born, we were born in this era of petrochemicals, electronics, and aviation. That was the wave. Thereon, we were there to see the software, digital networks, and mobility wave. That lasted for another 30 years. Dear professors, now we have entered a strategic wave. This is the wave of disruptions. In every industry, you see disruptions happening. The previous slide talked about the disruptions that are waiting to happen in education. So we need to gear up to face this era of disruptions. We need to be equipped. That is when we enter this wave as disruptors ourselves. And that is why let's understand what are the features of this particular wave, the era of disruption. Things are going to be nano, networked, autonomous, and hypersonic. People from the engineering understand these terms better. And the algorithms that are going to be written are going to have intelligence with quantum computing. Now we talk about quantum computing. And in terms of synthesis, there's going to be a synergy through biology, energy, and reality. So human beings are going to have the best of both the worlds. The body of a machine and the mind of a human being. That is humanoids, robots that are built with artificial intelligence, machine learning, quantum computing, and whatnot. So the best of the both worlds. Human beings are mortals. However, futurists, scientists say that human beings who are going to live forever and ever, defying death and aging, are already born and are living with us. Look at the challenge that are posed before us. Human beings who are never ever going to die, they're going to live forever and ever, are already born and are living with us. So, education cannot stop with 25 years of our schooling and undergraduation and post-graduation and PhD. It cannot stop there for the first 30 years. That makes learning lifelong. So, my dear professors, the imperativeness of today is to be lifelong learners. Look what Elon Musk says. Robots will be able to do everything better than us, everything. Because earlier they said there are certain things which the robots cannot do, like writing a poem, for instance, or in marketing, designing a ad copy, writing slogans, catchphrases, content creation. All these were the creative domain which only human beings could do. It was so unique to us because we were the only beings who can think. Today, the machines have started to think, and we'll have to disrupt this. We'll have to tide against this wave and be relevant as teachers. So apart from Tesla, Elon Musk works on various things. One is called the neural link. This neural link is a chip that is going to be ingrained in human brain. And Elon Musk says, let's take a physically challenged person who's not able to walk, will be able to walk seamlessly with this chip being ingrained in the human brain. That is the level of advancement in science. That is the era of disruption. So the challenges in terms of physical deformities are going to be overcome with the advent of this chip. You know how serious he is? He says, I've given one of my sons for this experiment to ingrain the chip in his brain because people will be apprehensive about this experiment. So just to tell people that it is absolutely safe, and I mean business, he is letting one of his son be experimented with this and a chip being ingrained in his brain. So education has moved to metaverse, be it any discipline that we are in. This is an article that appeared in Harvard Business Publishing, and it says business school in the metaverse. Likewise, engineering education or any domain, we will be moving to metaverse, be it virtual reality, augmented reality, or mixed reality, because that is where our students are. They're already into it, enjoying gaming. And why not we make education as edutainment? Education plus entertainment is edutainment. That is how we reach and be relevant to the millennials and our students. So I just want to introduce to you about 4 companies which have aced, which have been the numero unos even before the era of disruption started. Number 1 is Apple, and all of you know it is because of Steve Jobs. So though he was by profession not an engineer and by profession not a manager, he was an engineer and an entrepreneur put together. That was his way of thinking. That is why they were able to disrupt. My dear professors, let me take you to the 1970s. In 1970s, what happened between USA and Japan was Americans will invent so many things. Japanese will imitate them and give it to you at a better quality, at a miniaturized version. This was the strategy that the Japanese were adopting. The Americans invented the color television. The Japanese came out with the compact color televisions. The Americans came out with Harley Davidsons, the 350cc's and 450cc bikes, whereas the Japanese from Honda came up with Honda Cubs, the 50cc mopeds. So anything the Americans invent, the Japanese will imitate and give it to you at a better quality. In the 1980s and the early 1990s, this reversed through Steve Jobs. There's a book called Made in Japan, written by Ibuka, one of the co-founders of Sony. What he talks in that book is he goes to drop Akio Morita and Ibuka. Akio Morita goes to one of the co-founders of Sony, goes to drop his daughter during the 1980s, where she was going for a vacation along with his friends on a picnic. And he noticed they were carrying two luggages. One was their suitcase and the other one was the stereo system, the tape recorder. So everybody in the bus was carrying a stereo system with them because that was the only source of entertainment. And Akio Morita was wondering, how will they enjoy music at all? Because everybody is carrying a stereo and the bus will sound so noisy, like a pandemonium. They will not even have the privacy that is required to listen to music, and the stereo system was too big and inconvenient for them to carry. So Akio Morita disrupts the stereo system, brings in a smaller gadget, which they called it Walkman, and it had earplugs so that you listen to uninterrupted music and the external noise doesn't disturb you, neither you disturb others with your loud music. The Walkman was born. Sony became a great company because it disrupted. What Steve Jobs did was, this was the Japanese strategy I told you. Steve Jobs reversed it. He introduced a gadget which was smaller than the Walkman, and he called it the iPods. The iPods were smaller than the Walkman and had better quality. How many songs can your Walkman play from the cassettes? 30, 45? iPods were able to play 1,000 songs with very small chip. America celebrated this disruption. It was because they gave back the Japanese, that they paid back the Japanese in the same coin. So this, dear professors, is disruption. You reinvent, re-established some standard that was in practice. This becomes disruption. And thereafter, Steve Jobs didn't stop there. When it came to the world of computers, he introduced the desktops, the portable computers. Other big companies like IBM and DEC called it a toy. Steve Jobs knew that this was going to disrupt the way people used gadgets. They introduced graphic user interface in personal computers, which means the icons were introduced. You need not know coding to operate on a computer, else in previous computers then you need to know codes to operate on them. But if you want the larger masses to operate by these gadgets, you'll have to make it user friendly. The design of it was important. That, my dear professors, was Apple's style of disrupting the music industry and the computer industry. He did not stop there. Thereafter, he saw the mobile phones. Nokia was the market leader. BlackBerry was a premium phone. All of it had the QWERTY keyboards. You had to key. There were a lot of keys in them, in the keypad. Steve Jobs visualized that The phone should not have any keys at all. Generally, we do things with our fingers. So he called his engineers and said, create a phone which has just one button, and that should be the power button. All else, I should be able to do with my fingers. If I want to enlarge a picture, I enlarge it with my fingers. That is it. I should not be keying them. And that is how the iPhones were born. It disrupted the way we used mobile phones. That is Apple's style of disrupting. Jeff Bezos, one of the richest entrepreneurs in the world, he was a computer science engineer. You need to apply whatever you know. As teachers, this is very important. Otherwise, people will say that we are good at theory, we do not know to practically implement them. Because the humanoids are theoretically smarter than us, and they can also practically implement the theory that they have learned. Machines are learning. It is important that we also learn. So Jeff Bezos was an avid book reader. He used to go to various bookstores and buy books. The most popular was Barnes and Nobles, a chain of retail outlet called the Barnes and Nobles. When he wants to buy 5 books, there will be only 3 titles available. The other 2 will not be available. When he wants to buy 3, only 2 or 1 will be available. So he thought, why not I sell books through the internet? A disruptive idea was born. Jeff Bezos, being a computer science engineer, implemented something that he had learned and started selling books online. Thereafter, this bookstore, the advantage there was when you want 5 books, even though the other 2 titles are not available with you, you can always procure them and send it to your customers. If somebody wants to buy 10 books and you have only 5, you can buy the remaining 5 and send it to your customers. So you're delighting your customers through your disruption. Later on, he said, why only books? Let's sell everything available. And that is why in the Amazon's logo, you will see an yellow swoosh that goes from A to Z in Amazon, which means we have everything from A to Z. The next company that I would like to share with you is Alphabet. Their brand is Google. They have different brands. One of their brands is Google. Again, 2 research scholars. I'm sure there are so many research scholars who are going to present their papers today. To these research scholars, I dedicate this example. Sergey Brin and Larry Page were the 2 research scholars who were doing their PhD thesis in computer science about backlinks, about a search engine with backlinks. And even before they could submit their thesis and get their PhD awarded, they implemented this idea. They called their search engine as Google. My dear professors and research scholars, look at the way they implemented their idea. Look at their insights. The most visited page on earth today is Google. Most visited page. And did you notice the most visited page on earth does not have any advertisements? It has a lot of white space, no advertisement, with just the brand name Google written there. It is because human beings would want to start their day on a clean sheet of paper. Very little insights, but look how beautifully they've implemented all this. If I ask you to name other competitors' search site engines, it would be very difficult for you. In this world of competition, look at the monopoly that Google is enjoying. Similarly, Airbnb. Two young students, they were not even research scholars, they were undergrads, did not even have money to pay their room rent. Another 10 days they do not pay, they are going to be evicted. They do not have the money. So they get an idea. There was a conference that was happening in their university. Unlike today, we have the advantage of virtual conference. It was a physical offline conference that was happening. And so the hotels and rooms were fully booked. Their room was very big. They also had a air bed. So these two guys said, why not we rent this room? We'll accommodate other paying guests during the 3 days of conference. We'll get some money. With this money, we'll pay back the rent. So they put a small advertisement in the internet saying that all those of you who are searching for hotel rooms and are unable to find, we have an accommodation, a shared room. We'll give you an air bed and breakfast. So that is Airbnb, air bed and breakfast. Today in India, we have this concept called Oyo rooms, Ritesh Agarwal. But the idea birthed in US with Airbnb. So the way we book our hotels today has totally gone for a toss because of the disruptions that had happened. So this is the type of disruptive era that we are into. In the last 3 years, the industry of coffee business has been hit by 50%. 50%. Why? When they did a research, they found out something startling. What happened in these 3 years that the toffee business took a severe hit of 50%. 50%. Almost half their market share. Then they understood, ever since the pandemic struck us, people started to use fintech payments, be it Phone Pay or Google Pay or any such UPI. So what happens when you go to a grocery retail outlet? Earlier, you'll remember, if there is no change for 1 rupee or 2 rupee, they'll give us 2 toffees or 1 toffee. Meaning, I do not have 1 rupee, so take this toffee. Today, if it is 499, we pay 499. If it is 198, we pay exactly 198. The toffee business had competition not from another toffee company, but from a fintech player. Look where our competition is coming from. This, dear professors, is the era of disruptions. The arena is volatile, complex, ambiguous. This is called the VUCA world, and we are traversing in this VUCA world, and we need to equip ourselves to navigate successfully in this era of disruptions. So, as I told you, there are different professors from different verticals here. So, I'm just giving you the basics of what is the business that we are doing. Because oftentimes, this is misunderstood. So I'm just touching the fundamentals of business. You ask a pharmacist, a medical shop entrepreneur who has a medical shop, what are you selling? The pharmacist will say, can't you see? I'm selling medicines. But that is not the answer. Because the pharmacist has not understood the why. In business, you need to understand the why. What I'm trying to tell, dear professors, is the pharmacist is not merely selling medicines. The pharmacist is selling healing. The pharmacist is selling cure. The pharmacist is selling relief from pain. That is the why. It is not always the what and how. It is the why, the purpose. The Japanese call it ikigai. As fellow presenters in this paper, we need to ask this question. Why am I an academician? Why am I a research scholar? It is not merely to get a degree. It is not merely to share our knowledge. There could be different reasons of this why, shaping the dreams and careers of our young students. It could be to contribute a breakthrough research findings through our research papers and our theses. It could be anything. But let's not forget the why, because we are so engraved and busy in the what and how that we forget the why. It is very important that we answer this question, why? Look at this advertisement. Big beauty sale. Did they mention cosmetics anywhere? What are they selling? They're selling cosmetics. But they have answered the why. The answer of why is beauty. They have understood they're not selling cosmetics, they're selling beauty. That is understanding your business. Look, Coca-Cola. It is a sugar-coated, effervescent soda, water. But one of the best marketers in this world is Coca-Cola. It is because they've understood their why. They say open happiness. They don't say open a cola. Open happiness. I'm not saying this is right, but look at the intelligent manipulation they have done. Intelligent soul searching they have done to make Coca-Cola equivalent to happiness. Look at the tagline here. Your last opportunity to be part of a great lifestyle. What is this company selling? They're not selling flats or apartments. They're not into real estate business. That is their what and how. But their why is they have understood they are selling lifestyle to the buyers. Lifestyle, my dear professors, and not mere houses built with brick and mortar. Vival soap, what are they selling? There is this regional advertisement where Dal Divya becomes Dul Divya. And they ask you this question, beauty is in your hands. What is in your hands? Soap is in your hands. They don't even mention this word soap. They call this beauty. They have understood their ikigai. In the last 20 years, we have asked for just 2 minutes of your time. Maggie. Do not presume that Maggie is merely selling noodles. Once again, dear listeners, I'm taking you back to 1980s when Maggie was introduced. 1980 was a time when several of the women started to work as well along with men. So both the man and the wife came back home. The wife, the lady of the house, had additional duty of taking care of children. The children were hungry. Now the lady of the house is also tired because she had worked like the man, but now she has additional duties at home. So there should be a quick snack. She cannot laboriously work now, nor were there Swiggy or Zomato to order a quick snack for their children. She was already tired. Maggie made life easier for them. Just 2 minutes. You go to the kitchen and you have piping hot snack ready for your kids. Meaning, my dear professors, less time in the kitchen, more time for myself. It's called the me time. So, Maggie is not merely a noodle company, a noodle brand. It gives more time for the lady of the house. Less time in the kitchen, more time for yourself. How beautifully these brands have understood their rationale or the purpose. In this era of disruption, where the competitors for us come from artificial intelligence, it is very important that we understand our why and our ikigai. ICICI Prudential organized a competition for all these kids. And they said, draw what would you want to become in life? What is your career aspiration? So these little kids drew themselves as doctors and engineers and lawyers and teachers and whatnot. ICICI collected their data and sent these paintings back to their parents saying that your daughter wants to become a doctor. Do you have the money? Have you saved? Do you have a plan? Your son wants to become an engineer. Have you started saving for that? If no, please find the application and the scheme details. Fill it up and call us. We'll come and collect it. If you had merely told people that you need to save for your sons and daughters, that is different. But when you show a picture of your daughter, which she herself has drawn as doctor, you need to be a father and mother to understand the emotions that I am talking to you. All this is because they have understood the insights of human beings. So whether we teach engineering or humanities or management, we need to be insightful about our students. Look at this advertisement. This is for a karate school based in Singapore. Nowhere they have said you can become self-dependent, you can learn one skill, nothing. The picture says it all. You'll be so powerful that you can break this desk. Okay. They're not selling the concept of karate school. They're selling power, more power to you. Every child needs a family. Look at the emotional value that is attached. No big explanation. Just every child needs a family. Emotional appeal that they've used. They're not selling orbit chewing gums. That is the what and how. Chewing gums. They're selling bright smile to us. Happiness to us. That is how orbit is understood. We have just 5 more minutes, so I thought I'll stop here in case if we have any questions.
Thank you very much, Professor. Thank you. So,
Thank you, sir.
Our invited speaker, keynote speaker, Dr. Praveen Kumar, has taken us to an evolution for over 1,000 years, I think. It was really interesting, exciting, and we are very very much enlightened by your talk. I think it will be a great inspiration to all the young researchers and particularly the students and the research scholars from marketing, and also the professors who want to sell their ideas or books or whatever it is. It was really great to listen to your talk. I think this it has been recorded online. I think this will be watched by thousands of, even lakhs of people through our YouTube page, I hope. I am really very thankful to you. If there are any questions from the delegates, you are welcome. You can
Thank
raise.
you so much, sir.
Thank you, sir. Thank you, sir.
Sir, very, very nice presentation, sir.
Thank you so much, sir. Thank you so much, sir.
From audience, any questions from audience?
You can raise your hands, or else we will share the mail ID of our guest. You can also contact him for any clarifications. Anyway, thank you, Professor. Thank you very much for your enlightening speech and for sparing your time for on this Sunday to deliver the talk. It was really interesting. We are happy about it. Thank you, sir. Thank you.
Thank you so much, sir. Once again, I would want to thank the organizers and Dr. Kamraj for giving an opportunity to for all of us for this intellectual knowledge sharing forum. Sir, we expect you to organize many more such events so that the academic fraternity benefits out of this. Thank you so much, sir.
Thank you, sir. Thank you very much. Thank you very much. Dr. Balmuldaran is the next speaker available.
Yes, sir. IIT AKB Chand, sir.
Dr. AKB Chand is ready.
Yes, sir.
Good morning to Dr. AKB Chand, sir. Kindly.
Sir, actually, his time 10:45.
Oh, 10:45. Okay, 4 more minutes are there.
Yes,
doesn't
sir,
matter. Doesn't matter.
Yes,
we can spend a few minutes to the.
Sir, please give some instruction for paper.
Yes, sir. Regarding publication.
Full paper.
Yes, sir.
Full paper. How to prepare the full paper?
Yes,
what
yes.
are the things?
I will use this time. Dear delegate, hope you have listened to our invited speaker. Make use of the guidance. What is said in the career. Definitely that is going to help us in improving whatever the business we do for us or for our children in future. Okay. So let me say a few things about preparing papers for publication in the journals. We have almost received the full papers from all the delegates who wanted to publish their papers. However, a few guidelines I wanted to give you. See, the paper should be in a proper format. That is very, very essential so that the paper is taken up by the editor. Number one, your paper should be structured. It should have the title followed by authors' names, affiliation properly, along with the email IDs. And you should also mention, or there should be an asterisk for who is the corresponding author. That is very, very important. Whether the organizing committee, that means technical committee, wants to contact you regarding any clarifications about the paper, or the journal wants to talk to you for any clarifications, this is very, very important. The corresponding author should be asterisked. You should mark with a star for the corresponding author, and his email ID should be definitely mentioned under the affiliation, corresponding author mail ID. Then it should start with the paper should start with the abstract. Then this is followed by introduction, materials, methods, or body of the text. Then that is followed by results and the discussion. Finally, there should be a conclusion followed by references. See, the references should have the list of references, and those references should have been cited in the paper. For example, I have in my paper 25 references. So in the entire paper, I should be able to see where you have cited, which part of the text or paper you have referred to the particular journal or particular reference, maybe a journal or a book or a report, whatever it is. So starting from reference 1 to 25, I should be able to see the superscript as superscript in the text. All the 25 first cross reference they will do. The journal, any journal or editor or reviewers will go through whether you have properly referred, whether the cross reference is perfect. That is very, very important. First the format, then the cross reference they will check. If one of the references is not properly matching, if one of the references is not properly titled and numbered, the reference should have the standard details. I mean, in the standard format. For example, name of the author, then the title of the paper, then journal's name, volume number, issue number, then year. So all these things should be there when you all these things should be there when you present when you submit a paper. So please keep all these things in mind, and also don't present, I mean, don't give any image for tables. So it should be done using a program, so that it will be easy for the journal publisher to make any modifications needed to various, modify, for example, title or figure caption or whatever they want to do, they can do, so that they can accommodate in their journal as per the requirements or the style of the journal, format of the journal. So kindly bear all these things in mind and prepare the paper. And I hope these the list of journals will be sir. Have we shared the list of journals yesterday, or we are going to share today? Yeah, Professor Balamurugan, Balamuralidharan.
Sir, within 5 minutes he will come, sir.
That's okay. That's okay.
Okay, sir. I called.
Okay. What about the list of journals? Are we going to share today, or it is done already?
No, sir. We didn't share right now, sir.
Okay.
Yesterday night only prepared, sir.
Okay. Today we are going to share, right?
Yes, sir. Yes, sir. Today we will send a mail to all, sir.
Yeah. So today we are going to send the list of journals and how much time they are going to publish. Then all those details you need will be there, along with the website address. Everything is there. Please go to the website of the respective journal. You find out whether they are indexed or not, whether it is a UGC UGC journal. I mean,
Web of Sciences,
or Web of Science, or
SAE,
Scopus
all
Index.
types of indexed journal are.
Yeah, all kind of indexing you can check. UGC CAR journals also is there, and also the time taken by the publisher to publish those papers. So you, depending on your requirement and your desire, you can select any journal. And we are going to today share or make yourself available for a Google form where you are going to fill up the journal where you want to publish your paper. You can choose, you can carefully choose the journal you want. See, please remember in mind, once you choose the journal, then we cannot change it. We will process it for that particular journal. So the paper will be, the process will start immediately, and the publication time may vary between 2 weeks to 6 months. So it is all depends on you and your desire or your requirement, how much time you need. Some of the research scholars may be in the urge of submitting the thesis. They may require the paper to be published within 2 weeks or 1 month. So they can accordingly opt for the suitable journal, and accordingly the format and the references should be made. So though we have received almost over 250 full papers, we want you to resubmit all the papers with by considering the requirement of the respective journals. In case you do not have, if you have any difficulty in that, you follow the general guidelines that I gave for preparing a research paper. Accordingly, you submit. But the references should be proper. The references should have been cited everywhere. In the text accordingly, appropriately. That is very, very important. So kindly bear all these things in mind and submit the full papers. Thank you, delegates. The next invited speaker, Dr. A.K.B. Chand has arrived. Good morning and welcome you, sir. Dr. A.K.B. Chand.
Good morning. Good morning.
Very good morning.
Sir.
Yeah.
Sir, can I ask a question?
Yeah. Yes, madam.
Sir, just now you said that there are certain guidelines for each journals.
Yeah.
According to the journal.
Yeah.
So that is available on your Neurain's website or
yes.
journals?
Neurain's group.
Website.
It will be shared in the group.
Okay, you will share, sir.
Yeah, we will share.
Okay, okay, sir.
Thank you, madam. Thank you, madam. Let's start the session. Thank you.
Yes.
Professor Bala.
Yes, sir. Yeah, sir, very warm welcome, sir. A.K.B. Chand, sir. Very good morning, sir.
Yeah, good morning.
Thank you, sir. Sir, shall I start, sir?
Yeah, yes, please, sir.
Okay. A.K.B. Chand is a native of Bhubaneswar, Odisha. He received a BSc degree mathematics from Samanta Chandrasekhar College, Puri, 1994. MSc and MPhil in mathematics from Utkal University, Bhubaneswar, Odisha, in 1996 and 1997. He investigated spline and whole scenes fractal interpolation functions during his doctoral research 1997 to 2004 IIT Kanpur, Uttar Pradesh, India. He worked assistant professor in BITS Pilani, Goa campus to his postdoctoral position at the University of Saragossa, Spain in 2007. Since 2008, he has been working as a faculty at IIT Madras and currently he is a professor. He has been visiting professor at several foreign universities. His research group developed the theory of shape preserving spline fractal interpolation functions surfaces. Professor Chand guided 10 PhD students in theory and geometrical modeling of fractal functions and surfaces and published around 120 research articles. Notably, his research papers were in top 20 articles in fractal journals and Journal of Approximation Theory. His research interests include shape preserving fractals, approximation by fractal functions, fixed point theory, computer aided geometric design, wavelets, and fractal signals and image processing. Thank you, sir. Thank you so much, sir. Very warm welcome, sir.
Yeah.
Sir, please take over this session, sir.
Yeah, thank you.
Thank you, sir.
My slide is visible?
Yes, sir.
Yes, sir. Kindly
Okay,
go
so
ahead.
thank you very much. So today I'll talk about the nonlinearity through fractals. So my outline of this talk is what is nonlinearity and what is the mathematical background actually. So to approach the nonlinearity through this fractal, so therefore we need some basic mathematics there. Then we have to develop what is called iterated function system, and based on IFS you can construct fractals. Then here you can find several type of fractal functions and fractal surfaces are there. Okay, so at the end there is some applications apart from references. So if you see the history of nonlinearity in the mathematics, one can find the history of nonlinearity through the existence of continuous nowhere differentiable function. Okay, in around 1806, Ampere also tried to give justification that all functions are differentiable. Okay, but Bolzano actually first created a function which is not differentiable at any point, but it was published little bit later. Okay, So before that, actually, Weierstrass function was published. Similarly, cellular function, it was also published before Weierstrass functions. Okay, similar Riemann function, actually, he gives a function which is differentiable, but not differentiable at only few points, actually. So here these points where you will have derivative, otherwise it is nowhere differentiable. Weierstrass function, actually, so you can see this Wx equal in this format, k equal 0 to infinite a to the power k cosine b k pi x, a lies in 0 to 1, a b is bigger than 1 plus 3 pi by 2, and b is bigger than 1. This is an odd integer. If you take in this format, you will find a function which is nowhere differentiable. Okay. So similarly, here you will find the Darbox function. Similarly, you will find infinite number of functions actually which are very irregular. So based, so all these functions actually you can see all these are non-linear in the nature because they are not smooth actually. So you will find very irregular functions. So therefore, this is the Bolzano function. Initially, you take a straight line, then you construct break it actually in two parts, and you generate new points where it has two tangents. Similarly, you repeat the process. Okay, again you create the function where it does not have tangent. It has more than two tangents, so that function is not differentiable at more number of points. Slowly it will be an overhead difference. So it is a constructive way one can construct it because you have to see the limiting. Okay, limiting value. So limiting function is an overhead differentiable function. So similarly, you'll find these are cellular function or Riemann function. So all these type of functions one can find in the stock market, or if you take any sorts of temperature data or any nonlinear or any experiment in the chemistry or Hamiltonian system. Okay, so in various places in physics, chemistry, and all natural sciences, you'll find. In nature, actually, if you see the lightning or any other very irregular curves, there also you'll find all these type of nonlinear functions are there. Okay, so similarly here you can see a very nonlinear complicated structure like you take a triangle like this area. So here you can see the side is 1. So here if you create this one side, here 1 by 3, 1 by 3, here it is 1 by 3, 1 by 3. So this length is 4 by 3. So if you do the same thing here, you will find this length is 4 by 3 square, so 4 by 3 cube. So if you go to the limiting process, you will find limit n to infinite 4 by 3 to the power n. So one side length is going to infinite. So you will find a curve actually. So whose length is infinite, but its area is finite. So you can put the curve inside a rectangle. Okay, so you will find the area is finite. Similarly, one can construct the piano space filling curve. Okay, so you can take this structure and again you repeat the procedure here. Okay, so basically one can get a function from one dimension to two dimension, a continuous function. Okay, so similarly here you have several type of nonlinearities there. So in the if you see the nature actually mountain, okay, so all these clouds, everything here you have actually corn, all these trees are there. So you cannot approximate this by traditional tools available in the Euclidean geometry like triangle, circle, semicircle, all these tools are available. If you put them together and try to construct this one, these pictures, it is not possible to construct them. So that's why we need actually something extra. So we need some nonlinear tools actually. Okay, so therefore this nonlinear tool that will come through the fractals. Okay, so therefore there are some problem when you approach to the limited tools which are available in the Euclidean geometry. So you need actually a better tool, so that's why we go for this what is called fractals. So there in order to construct these fractals actually you need something called iterative function system. So there are certain backgrounds are required when you go for the fractals. So this is a bisection method actually, you know how to do this one. It's a feedback process. Okay, so when you repeat certain process, slowly it will become very complicated. Okay, so this is a bisection method which is based on intermediate value theorem. And because what happened in bisection method, you take one root, then you find the next root, again next root will based on the next root, again you will find the next one. Okay, so that's why it is a like a Xerox procedure. Okay, so give one input, then you get the output. From output again you give the input. So intermediate value theorem, you know if a function is continuous. Okay, so if you take any number between a and f of a and f of b, there exists a point xi actually in this interval, so that f of xi equal to k. So therefore you find f of a and f of l. If fx is a continuous function, so you'll find when there is a point a and b for which f of a and f of b is less than 0, you'll find there exists a root in between these 2 points by using IVT. So similarly, you have Cantor intersection theorem. If you have a nested interval, if you take limiting process, you'll find it has unique point. So therefore, this is the bisection method. I think everybody is familiar with the bisection method, how to find the root of this. Okay, so you take the initial approximation as a plus b by 2. Okay, then you check where your root lies. Okay, if this is input, this is output. Okay, again output will go as input, then you repeat these procedures. That's why it is explained through the feedback process. Okay, so this question is whether you can do the similar feedback process, whether one can construct the very complicated objects or nonlinear objects which appear in the nature. So here Newton's absorption method, it is also a very similar feedback process, xn plus 1 equal xn, f of xn divided by dash xn. So you know x0, then you get x1. Okay, from x0 you are getting x1, from x1 you are getting x2. Okay, so similar from x to x3, this is a repetitive process, so that's why this is called feedback process. So I will skip this thing. Fixed point theorem, it is very important. Okay, so if g is a continuous function, so that g of ab is contained in ab, okay, and g dash x is less than equal to k less than 1, then you'll find there exists a fixed point, and this fixed point is unique, and one can find there is a function g for which x plus 1 equal to gxn. So this iteration will converge to the chi. Okay, so this proof I'll skip it for the time being. Okay, so one can see actually when the fixed point theorem will converge. Okay, so when this root lies between this derivative lies between -1 to +1, this will converge. If you start here, it will converge to the root. Similarly, here anywhere you start, it will converge to the root. Other case, it will diverge because this derivative value is bigger than 1. Okay, so for this IFS, I need what is the metric space. So metric space actually need a metric which will satisfy these 4 conditions: d of xy greater than equal to 0, d of xy equal to 0 if and only if x equal to y, d of xy equal to symmetricity, here it is triangle inequality. So this is a metric space. So one can construct different type of metric here. Okay, so therefore when two metrics are equivalent, we will find a two constants C1 and C2, so that C1 d of xy less than equal to d star xy less than equal to C2 of d of xy. Okay, so this is a Cauchy sequence. So if this condition is true for every epsilon, you will find n and m for which d of xn minus xm is less than epsilon. Okay, so this is complete if every Cauchy sequence is convergent. Okay, and in the contraction map, you will find if d of t of x, d of y less than equal to q times d of xy, this is a contraction map. Okay, Banach contraction principle would say that if the map is contraction and the original space is complete, you will get a fixed point there. Okay, and the fixed point can be obtained by the iteration of this feedback process, xn equal to txn minus 1. Okay, so then you have some familiar definitions like open ball, what is open ball, what is bounded zero limit point, closed set, closure. Okay, so this is actually, I need this one. So one can, for a non-empty complete metric space, one can define what is your hyperspace of x by h of x equal to subset of all non-empty subset of x of the A is compact. Okay. So therefore, if you take this space, so either you can define a metric here, so one can construct d of x equal to minimum of d of xy, where y belongs to b. Okay, so this is called distance between x and b. That means you take a point, you take a set. Okay, then you construct the minimum distance here. Generally, we do that by finding the perpendicular distance from a point to a set. Okay, so therefore, since it is a closed set, you will find a bx for which distance between x and b is going to be distance of x dx. Okay, so that's why this is equal to 0 if x belongs to b. Okay, so similarly, b contained in c, so you will find distance between x of c is less than equal to, because here you are taking minimum over a larger set. Okay, so therefore one can think of what is your d of AB. Okay, so because you are defining the distance between point and set, now you can vary this value of x. So therefore, if you vary, you will find maximum of this value. So therefore, one can think of this is a distance, but this is not a distance. Actually, this will not satisfy all the properties of the metric. Okay, so therefore, one can find d of AB equal to equivalent to d of A star B star. Okay, so if A is contained in B, d of AB is less than 0, but in this case, d of BA is bigger than 0. Okay, so therefore what will happen actually in this case, this is not a metric, because one case it is positive, one case it is 0. Okay, but because the metric has to be symmetric, so therefore this d will not act as a metric in h of x. Actually, this is your hyperspace of all these non-empty compact subset of x. So we need actually how to define the metric. Okay, so here some properties of this d is required. D of AC is less than equal to d of AB. And d of A union BC is equal to maximum of difference between distance between AC and BC. Similarly, if you take the d of AB less than equal to d of AC plus d of CB. Okay. So therefore, we can define what is called Hausdorff distance, h of AB equal to maximum of d of AB and d of BA. Okay, if you take d of AB equal to d of BA, in that case, so this will symmetricity will be there, and all other properties are valid. Okay, so therefore one can say h of AB greater than equal to 0, h of AB equal to 0 if and only if A equal to B. H of AB equal to H of BA, H of AB equal to H of AC plus H of CB. Okay, so therefore it will satisfy all the properties. So therefore H of X and H are simply H and H. This is called a metric space, and this is actually a new metric space coming from XT. So this is called actually Hausdorff metric space, from which is constructed from X. Okay, so there are completeness principle. Okay, so let XT be a complete metric space. So then this is H of, if this is complete original space, because this hyperspace is defined through this space. So if the original space is complete, this space is complete. If this is compact, this is going to be compact. Okay, so therefore since it is a complete, if you take any Cauchy sequence, it will converge. Okay, then this is the result is called, if every contraction map is continuous, one can prove it. Similarly, if this is a continuous map, so this will induce a map on Hx, which is also a continuous. Okay, so this is a contraction map with contractive factor S. So therefore, if you see the induced map also, this is also contraction with contractive factor S. So there is something actually where you reach actually now iterated function system. Okay, so this is given as you take any set and then you collect the finite number of maps, okay, which are continuous. Then this is called iterated function system. Okay, hyperbolic IFS means if all these maps are contraction, this is called hyperbolic iterated function system. Then one can define actually based on this elementary maps, one can define what is your W of A. This is equal to capital W of A, union of N equal to 1 to N Wn of A. So if you take 4 different sets B, C, D, one can prove that H of B union C and D union E is less than equal to H of BT, maximum of H of BT and H of C. Okay. So you can take the first two and last two, then you will take the maximum distance between these, that will satisfy this inequality. Okay, so similarly, if you take any number of n number of maps and you are able to define n number of map here, okay, W1, W2, Wn. So this W actually, so what is the contraction map? If each of them is contraction, then capital W contraction, this is also contraction map. This contractive factor is the maximum of S. Okay, then fixed point theorem, it says that if this is capital X, this is a hyperbolic IFS with contractive factor this, then Hutchinson map, you are defining Hx to Hx, and you know Hx is complete metric space, because if this space is X is complete, this is a complete metric space. So you define this a map, this is a contraction map, and this has a contractive factor S. So therefore it is a complete metric space, it is a contraction, so this will have a unique fixed point. Okay, so that is written as G. So this is G is called attractor or deterministic fractals or hyperbolic IFS. Okay, so that's why one can construct very irregular objects by using the simple technique. Okay, so you need n number of maps, okay, for which you can represent a very complicated object. So like coral, tree, leaves, crystal, several type of mathematical fractals, and all these things are there. Okay, so therefore if you take Hx and H, so this H is coming through X, and this D also, this H is defined through this D. This, okay, because Xt is the original metric space. We are defining a new metric H, so therefore this is your new metric space. This is called the space of fractals. Okay, so this fractals actually, this word is coming from this word fractals. That means you break the object. Okay, so like which is fractal, like if you see the broccoli or any tree, actually you take the big set, original set, you take any part of this set, okay, what will happen actually? So if you break the original part into a small part, you will find the small part is very similar to the original. Again you break it, again you will find the small part is very similar to the original one. So you can see in the broccoli, you take a original broccoli, you take any part of the broccoli, again you break it, again you will find it similar to the original one, again you break it. So in the similarity actually, it will be there for certain degrees. Okay, so therefore this is called self-similarity, which is there with the fractals. Okay, in the nature, most of the things are fractals, but it's very difficult to observe it, okay, unless you go it or zoom it in minutely. Okay, so if you see our body tissue or something like that, if you zoom it, again it will find a similar structure, again you zoom it. Okay, so if you zoom it around 8 times, you'll find the structure are very much similar. Okay, so therefore, even if you are able to see everything is smooth, but it is not true actually. So there is something is called self-similarity, everything there is. So same thing is there inside the body. Okay, so what is fractals actually? So like a life, you cannot define what is life actually. Okay, so what is the living being? Okay, what is life actually? So there are certain characteristics to define the living objects. So same thing, fractals. So it is very huge actually. So you cannot take one definition until this is fractals. Okay, so therefore you have all sorts of mesh will be there. So that's what will happen actually. We attribute few type of features actually. Okay, so this type of feature is there, then we call this fractals. F has details on arbitrary small scales, that means you break it, again you'll find very minute things are there, again you break it. So arbitrary small scales, you'll find the similar details are there. Okay, so it is too irregular to describe through Euclidean geometry. Sometimes it has self-similarity, it may be approximate or statistical. Okay, usually find the fractal dimension of f is greater than or equal to topological dimension. And in most of the cases, it is defined recursively. Like if feedback process, you take one element and again you feedback it, again you get output and again you take output as input. So that's why this is the way one can generate the fractals. Okay, so here you can see the Cantor set. So this is very complicated object. So if you count the number of points, that is equal to infinite number of. What is the length actually? Length is whatever you are removing each stage. You take the entire 0 to 1 line, you remove 1/3, again you will find 1/3 here, 1/3 here, again you remove 1/9 here, again you remove 1/9, again you will get this part, actually 4 parts, again you remove 1/3 from each part. So you do this process, the limiting value actually you will get the Cantor set. Okay, so therefore Wx equal to 1 by 3x, that means this complete object. So if you take 1 by 3x means you are generating this part, and for this generation you need actually 1 by 3x plus 2 by 3. Okay, if you take union capital W equal to union of W1, W2. Okay, then you apply, take any compact set and apply this iterations, you will find after certain stage you will find this complicated Cantor set will be there. Okay, similarly you have the Assarin speak triangle. Okay, so if you want to generate this picture, okay, you take a triangle, you remove 1/3 middle actually, again you do the same process. Okay, again you do the same process, you continue. So therefore if you measure the distance, how much area actually you are removing, you will find the area is equal to what is the original area of the triangle. So that means there is an object actually whose area is 0. Okay, but if you measure the length, it is going to be infinite. Okay, so therefore one can measure the perimeter of this triangle actually, so one can find that is equal to infinite. Okay, so these are some mathematical pathology where you have the nonlinearity will be there. Okay, so these are also nonlinearity, coral or tree or leaf or feather, all these objects can be constructed through fractals. So it is not natural actually, so these are constructed through fractals by using some rendering algorithms. So now we'll go for this construction of the fractal functions. So you take x and y n. So these are some interpolation data. So our aim is, suppose you have very irregular function or nonlinear function is there. So you want to feed the data through a suitable function. So here I is the original interval, in is the subinterval. So one can think of constructing contracting map from this entire interval to subintervals. In this case, you have n plus 1 points are there. That means you have n subintervals. So you can get n number of maps 1 to n actually. And here, since it is going from 1 for x0 to xn minus 1, xn to xn, you will have actually two constants are there, two conditions are there. And you can find what is the value of an and bn. Okay, similarly, if fn is a map from I cross r to, in this manner, fn of xy equal to alpha n y plus q n x. So here wn xy equal to ln x, fn xy, so that these conditions are true. Okay, so therefore, for simplicity, if you take q n x, here you can take actually c n x plus dn. Okay, and alpha is a free variable. Okay, you can give any variable in any value between -1 to +1. Okay, +1 and -1 is not included because you have to use the fixed point theorem where you need the contraction factor to be less than 1. Okay, so therefore, if you take qn x equal to cn x plus dn, you can get the value of cn and dn. Okay, so it says that there is geometric d on R2 equivalent to the Euclidean matrix, so that this Wn is hyperbolic with respect to the d. Okay, so how do you look at the Wn? So you have two maps, one is ln, another is fn xy. If you combine them together, you will find this is a map from R2 to R2. Okay, so therefore this is a hyperbolic. That means of all these maps are contraction in the ratios. So how to prove it? If all cn's are 0, you take theta equal to 1, and you will find actually this metric is equivalent to now L1 metric. L1 metric is equivalent to L2 metric in R2, so therefore it is obviously true. Otherwise, if theta is equal to non-zero, if all ci's are one of the ci is not equal to 0, this value will exist. Okay, you define theta in this manner. Okay, then one can prove that this theta is less than 1. So therefore, you will find this is a contraction map. Okay. And in the complete matrix space, you will get a fixed point, which is nothing but W of G equal to G. So this W can expand in this manner. Okay, this abstract for G. So in the theorem 1 is the graph of a continuous function, so that f of xn equal to yn. This graph is called fractal interpolation function. Here you take all this space of functions g of x0 equal to y0, g of xn equal to yn. This is a complete metric space. Okay, so this row is also to a metric space. Now you define a RB operator like this. Okay, so one can prove that this RB operator is a contraction. Okay, and it has a unique fixed point. It will satisfy this condition. Okay, so therefore this f is defined recursively. Okay, so this f is self-affine or self-similar in the nature. Okay. And if qnx is a affine function, this is called affine fractal functions. Okay, so therefore what is called fractal dimension, if you take any set, if you count the number of balls which is covering this original set by a ball of radius epsilon, so this is equivalent to number of balls actually which is covered to cover A. So if you take a limiting value of this limit epsilon tends to 0 logarithm of n of a epsilon by log of 1 by epsilon, if this value will exist, this is called fractal dimension of it. Okay, so this is the fractal function. You take some 4 points, then you apply the procedure. Again, you'll find here alpha n values are given. Okay, and these are the 0.000.41. So you can see very nonlinear function is coming at the end. Okay, so therefore one can construct this type of nonlinear function which is available in the stock market data or study of spectrum. Okay, or in physics. Okay, so you can use it plentifully. So this type of fractal function, because you have the now functional expressions. So earlier we had the problem, we had the data, but we don't know what is the functional expression for our data. So now we are functional expressions are available. Okay, based on your approximation, so you can use it. So then there is something called collage theorem. Suppose you want to approximate a target T actually. Okay, so this question is if you construct an IFS, okay, n equal to 1 to n, wn. So this is your n number of maps, so that this quantity is less than epsilon, T is your target. Okay, so you define n number of maps and then you see the distance between T and WNT or the union of this is called capital W of T. This is less than equal to epsilon. So in the fractal procedure, whatever attractor you are going to get actually, G is the attractor. So this distance is less than equal to epsilon by 1 minus n. Okay, so that means practice it says that if you choose your Wn very close to 0 actually, then obviously 0 by something 1 minus alpha, this is equal to close to 0. That means this G is a very good approximation to your T. Okay, so therefore how to do this one, everything is required here. You know the discrete Fourier transform to find the points where you have to do the interpolation. Okay, so therefore the shape of G depends on the choice of scaling factors. So this can be resolved by the using some optimization technique. So then you have something called hidden variable fractal function. So if you define your alpha and y plus beta and z plus p and x, here it was, so that means it is a map. Originally it is given in R3. Okay, so therefore one has to define actually alpha and y plus beta and z plus p and x. So similarly here it is like this. Okay, so from the original data you are adding first zn. Okay, then you are doing this interpolation procedure. Okay, and here you'll find a graph which is in R3. Okay, so if you take this projection into R2, then you'll find what is called hidden variable fractal function. You are ignoring these values, or the parameter of these values actually, they will control the shape of this function. So therefore, you'll find two functions, f1 ln x equal to alpha and f1x plus beta and f2x plus pnx. Similarly, f2 ln x, this is delta and f1x gamma and f2x plus pnx. Okay, so these are a little bit complicated because alpha n depends on. So here I think you can see all these non-zero factors are there. Because when you construct f2, you need gamma n. So ultimately every factor delta and everything will be dependent here because f2 is defined through delta n and gamma n, here beta n is multiplied. So f1 is again depending on all these four parameters. Similarly, if you see f2, it is again depending on this. f1x, f1 is depending on alpha n and beta n. So ultimately f1 and f2 they are depending on all these parameters. So that's why it is very difficult to use. Okay, but one can use for the practical life of modeling problem in the diverse areas. Okay, so similarly, these are the projection of the function, so they are not going to be self-similar. Okay, self-affine the nature. So similarly, what you do actually, if you choose your alpha n, delta n, gamma n in a suitable well, okay, so therefore you'll find this is a fractal function which is self-affine or non-self-affine. If you take delta n equal to 0, you'll find modulus of alpha n is less than equal to modulus of gamma n is less than 1. Modulus of beta n is less than 1 minus modulus of gamma n. So therefore, if you choose in this manner, is a restricted or constant free variable, and here delta n is also 0. So there is no restriction. Alpha n and gamma n they are also constant variable, okay, because the value has to be less than equal to 1. Okay, so your graph of this coalescence hidden variable fractal function, the projection of the attractor in the R2, because the data was given in R2, you are extended to R3. There you are constructing a fractal function in R3, then you take the projection to R2, so therefore you get the fractal functions in R2. Okay, so one can observe what is the smoothness analysis, so one can find this is very complicated function, so it's modulus of continuity equal order of x to the power delta into log of mod x to the power n. One can see that paper. So similarly, this is the idea how to, because these are the interpolation points 0, 0, 2.357, 0.754, 1.9. So therefore, what we'll do here, you can take the standard FIF, then you change the value of beta n, gamma n, zn. Okay, you change the value of scaling, which is close to -2. You'll find this is a very like a space filling curve actually. So if you very close to 1.999, slowly this will be filled up. Okay, this is self-affine CHIF. Okay, so therefore if it does not depend on the projection, then it is going to be self-affine, or you choose your parameters so that this is going to be self-affine. Okay, so if alpha n is less than 1, gamma n is less than 1, beta, this is a restricted free variable. Okay, so this is the free variables. One can put the restriction according to this. Okay, but one has to see what is the variation of gamma n. In order to maintain the continuity at the edges, so you can define this one. Okay, so therefore you can see this IF is there in R4. This is WNM, so this will depend on this LNX, LM delta Y, GNM XYZ. Okay, so then you define what is the attractor. So one can get the attractor here. But under this condition, alpha n plus beta n equal to gamma n, Zn equal to delta TNM. So you'll find this is a self-affine. That's it. Because if you put the projection, but under certain conditions, it will match with the second coordinate. Okay, in that case, you'll find second coordinate and third coordinate will match, and third coordinate is a fractal function. So therefore, they will match. Okay, so these are the few fractal functions. So like if you're approximating a cloud, you'll find this type of functions are more useful because you are finding these are the given the details. If you do any part of this function, I can find it very similar to the original one, and they are very complicated boundary. Okay, so similarly, there is something called spline F5. One can construct the fractal functions. Okay, if you integrate it, it is a smooth one because fractal functions are very irregular. If you integrate it, it is smooth function. Now the question the reverse way. Okay, whether you can construct the fractal functions which is passing through certain points, but derivative is irregular. Okay, so we will not simply integrate. We want to construct the function directly. Okay, so this construction was given by Bransley actually. He started this work, but it was very complicated. So that's why we simplified it. Okay, so here you have R as differentiable fractal function. We know actually the function is affine FIF. Okay, so this polynomial actually, if you want R times differentiable, okay, so you have to impose the condition that it has to integrate R times. Okay, so therefore you will get a polynomial of degree R plus 1. Okay, so similarly, if you want actually here, we want this function to be R times differentiable, so therefore we have to choose actually alpha n is less than a n r. Okay, so this is the requirement, first requirement, necessary condition. Okay, so therefore here you choose Qnx is a suitable polynomial and alpha n has to be less than a n r. Okay, so therefore it will give the T is a contractive map and then you can proceed. Okay, so here you have to find how many unknowns are there, how many join of conditions are there, and can see actually how many continuity points are there because this function has to be differentiable R times, so therefore this has to be continuous everywhere, otherwise it's not differentiable, so therefore you will get these many conditions, these many nodes. Okay, so therefore you will satisfy the derivative will satisfy this condition, so you give the how many interpolation conditions are there, then you combine everything, you'll find the number of interpolation condition and number of unknowns, they are differ by n. So therefore you see they are differ by. Okay, so therefore you need actually R number of. So here you can see total number of unknowns is R plus 2 plus n plus 2R. Total number of condition is R plus 2 plus n plus R. So if it is the deficiency is R. So that means for rth degree polynomial, so you have to choose R number of functions. Okay, if it is twice differentiable, you need only 2 conditions. But if it is R times differentiable, you have to choose R number of conditions. Okay, the principle of construction of the differentiable fractal function is you just choose these unknown functions, okay, by using suitable conditions on them. Okay, so therefore we'll find all these coefficients as well. So because number of unknowns and number of equations are going to same based on your additional condition, so therefore you get the unique fractal function. Okay, similarly one can construct the fractal function based on moments, means second derivative at the grid points. So this is the procedure, so I will skip it. Okay, so therefore one can prove the convergence results, so when it will converge fast, when it will converge slow. Okay, so these are the fractal functions, okay, which are they are interpreting the same data, but one can see the structures are very much different. So similarly, what is called natural bicubic spline fractal surface, that means you will construct the fractal surfaces in the cardinal basis. Okay, so you'll find fn xi equal to delta ni if n equal to I, otherwise it is 0. Okay, so this is the IFS actually. So wn I xy equal to lix fn I xy. Okay, so this is defined here fn xy. So lix equal to aix plus bi, fn I xy equal to ai square plus alpha y plus ai square qn ix. So these are some bases. Okay, so by using these different type of bases, one can construct different type of fractal surfaces. But in classical case, you observe these bases are symmetric. That means this color actually, so pink color and this orange colors are very similar in the nature. So here you can see this one and this one is green and this violet colors are very similar in the nature. But if you take the fractals one, this is also similar as long as the scaling factors are same. The scaling factors are different means you'll find they are not symmetric. It is happening here. So therefore, what is natural bicubic spline? It has
Professor,
yes.
it takes 5 minutes, sir. 5 minutes more.
Oh, okay. So
Other
here
speaker
this,
also waiting.
bicubic fractal surfaces. So you take the cardinal spline in the x direction and y direction. Okay, then you do their blending using the. So this is the phi and psi. So these are the these are the some cardinal splines. Then you do the blending work. Okay, then one can define the fractal surfaces, which is very smooth actually, and but it is one can change actually. In the classical case, you will get only this type of surfaces based on your data, but fractal case, if you change the parameters, you'll find different type of surfaces. Okay, so these are different type of fractal surfaces for the same type of data. Okay, so similarly, one can construct the cubic Hermite fractal function where the derivatives are first derivative is irregular, so I'll skip it. One can construct the first order. Okay, so this is there in our, we developed these things actually, how to say preserving, how to construct the fractal function of within the rectangle, and how when it will be monotone, when it is convex. Okay, everything is given here. Okay, so this is a fractal spline with different different type of scalings. Okay, if you change alpha 1 here, you'll find a different type of shape. Similarly, if you change alpha 2 and alpha 3, you'll find different shapes are there. So these are the derivative. Derivative are you see very regular. So that's why those functions are called fractal functions. Okay. So similarly, one can put the fractal functions over the rectangles. Similarly, one can construct the rational functions. One can construct the function which is positive here, somewhere monotonic, somewhere constant, somewhere concave. Okay, all these different type of fractal functions, self-preserving fractal functions are possible. Okay, one can see the positive rational function. Okay, similarly, it is contained within a rectangle, but derivative are irregular. Okay, so therefore, one can construct the function which is smooth, but derivative is irregular. Okay, so these things are given. Similarly, we can construct the fractal surfaces. Derivative, partial derivatives are very irregular in the nature. One can construct trigonometric surfaces. They are also very irregular in the nature. Their derivatives are, one can see they are very irregular partial derivatives. Okay, similarly, you have another type of fractal surfaces which is very irregular. So that we are presented here. Okay, similarly, one can use the fractal functions in the machine learning or deep learning. You can take the fractal pictures, okay, like fractal dimension and other things. Then you can apply them in the deep learning. Okay, so you trained your neurons to identify on various aspects of the fractals, like fractal dimension or scaling factors or the shape parameter. Okay, so you have to. So there is a master thesis on this machine learning and fractal geometry. If you want to go through the details for the recent application, one can see it. Similarly, it has real-time applications in the automatic colorization of black and white images. Okay, automatically adding sound to silent movie. Several things are possible by using this real-time application of this machine learning through fractals. Okay. So I'll skip these applications of MI through fractal. Similarly, one can use the fractal dimension or the feature of machine learning. Similarly, there is a called fractal signature that can be used in the two-dimension images. Actually, how to use the fractals in the machine learning through this fractal signature. Okay, similarly, one can take the cancer image and find the fractal dimension on fractal signature. Okay, then you can train actually to see any image of a patient whether they have cancer or not. Okay, so therefore there are several work has been going on how to apply fractals in these images in the cancer propagation or satellite image or in various applications. Similarly, in signal recognition also you have different type of fractal dimension is there, box dimension, Karj dimension, Higuchi dimension, Petrosian dimension. Okay, so different dimensions are there. You can use actually this one to. Okay, this is signal pattern recognition based on fractal features and machine learning. So one can see this paper. Similarly, correlation dimension is there. Okay, similarly, how to use it in neural networks. So these are some application signal and image processing. Okay, one can see these papers for applications of fractals in the image processing or signal processing. And similarly, in the computer geometry or geometric modeling, several applications of fractals are there. Okay, so it has plenty of applications. So one can use this as a tool and apply in any science or engineering problems. Okay, similarly in biology, physics, engineering, so you have plenty of new books are available. A lot of developments have been done recently on this application of fractals in physics, chemistry, biology. Okay, and in stock market or image processing or engineering. Okay, so these are a few of our contribution to the fractals. Okay, so thank you. So this is the fractal garden.
Sir, thank you, sir, very much. Thank you, sir. Very nice presentation, sir.
Thank you, Professor A.K. Bichan.
Yes.
Thank you very much for the very good and inspiring talk. We are really happy that you are here to grace our international conference, and you have spent your valuable time on Sunday to share your research on this topic. Thank you very much, sir. Thank you very much.
Audience, any questions from audience? If you have any doubt, please send a mail to Sir A.K. Bichan, sir. He is highly talented person in IIT Madras. Sir, already 10 student completed PhD from sir. Any doubt on the related books and articles? Sir published 20 top articles in fractals. Okay, any questions from audience? Thank you, sir. It's a very nice presentation. Thank you so much.
Thank you very much.
Thank you so much.
Thank you, sir. Thank you, sir.
Okay.
Sir, Putli Bhai, madam already joined, sir.
Okay.
Madam, very warm welcome to New Rains, madam. Putli Bhai, madam.
Yeah, good morning, sir.
Good morning, madam.
All of you.
Good morning, madam.
Sir, am I audible?
Yes, madam. Yes, madam. Shall I start the intro, madam?
Yeah, sir, we can start. Already we are late at how many?
Yes, madam. Madam, 30 minutes, please take, madam. Actually, 1:33, madam. Time.
Okay.
Sharply, please complete 12 o'clock, madam.
Yeah, sure,
Lot of students are there for presentation, madam. Lot of students are there, madam. Presentation. Please complete 12 o'clock, madam.
Sure.
Okay. Dr. G. Puthilibai, Professor, Sri Sairam Engineering College, Chennai. Ma'am, you have given lot of intro. Some important only I tell you, madam. College topper in chemistry at UG level, university rank at PG level, women championship for sports. Okay. ACT, MOE, IIC at innovation ambassador, advanced level. ISTE, Best Women Engineering College Faculty Awardee. Successfully participated as a keynote speaker. Okay, Ramya, please mute yourself, please. Ramya. Okay, thank you, madam. Successfully participated as keynote speaker and session chair for the world record event of 150 hours continuous presentation, World Book of Record holder. Maximum next record maximum patent filled together in a single day by an individual for various innovative young woman scientist award, Dr. Kalam Educational Trust, award of excellence for Roman, successfully completed lot of courses NPTEL MOOC SWAYAM like, successfully completed 120 plus online courses. Mentor of appreciation, okay. 70 plus invited talk, keynote speech, expert talk delivered, acted as panel member and resource person, doing 2 consultancy research grant received from Nobel Professional Foundation as a PI, 2 granted patent commercialized, proprietor Infotech Advanced Solutions, acted as jury, panel member, chairperson, resource person, received mentor appreciation for the evaluation of projects, best paper award presenting the technical paper in the international coverage several times, best mentor award, mentor of appreciation MOOC, AICT, NPTEL, IP intellectual property award 2022, patent award 2021, having a maximum number of patent and spreading awareness and guiding students and faculty to draft and file patent. Number of patent technology plus design field published granted 45. Number of publications, journals, conference and book chapter 100 plus. Number of online courses 130 plus. Number of invited talk, keynote talk, panel member, resource person 70 plus. Number of FDP, STTP, SDP, seminar, workshop attended 120 plus. Number of FTP, STTP, SDP seminar plus workshop organized 50 plus, etc. Lot of things are there. Very warm welcome, madam. Very happy to introduce yourself, madam. Madam, thank you, madam. Please start, madam.
Yeah, sir. Good morning. And thank you so much for your elaborate introduction about me, sir.
No, madam. Lot of words I skipped, madam. Thank you, madam.
Okay, I'll share my screen, sir.
Yes, madam. Yes, madam. Madam, that 12 o'clock, please sharply complete, madam.
Yeah, sure, sir. That too, I can understand. Today is
Yes,
Sunday, and
yes, Sunday, madam. Lot of
people are
people,
waiting.
absentee students also joined today, madam.
Okay, okay. I won't take much time, sir. At the maximum, I'll try to complete it.
Thank you, madam.
Then I just give a brief introduction about the title, and at the same time, my presentation maybe instead of giving the instructions regarding what is nanoparticles and how to synthesize metallic-based nanoparticles in depth and explaining the different types of methods in detail and its properties and applications, I'll just give the outline of these things, and at the same time how the that is previous researchers they have covered and they have approached the synthesis of nanoparticles and how they have published and while choosing the papers, and this will be most benefited for the students, those who are trying to do the PhD works, that is yet to do the PhD work, and how to choose your PhD top in that way which will be utilized. How to do the literature survey, in those way I will give some guidance for you. Initially, I'll start with a brief introduction about the nanoparticles. So as you are all aware, I need not to cover that is the introductory part of the nanoparticles, as most of the people you are aware that what is nanoparticles, what is its importance, what is its properties, and where are all which will be applicable, and somehow you might have having some idea. So in that way, I'll start with the different aspects of approaching the nanoparticles and its synthesis. And if we talk about the nanoparticles, the most commonly used metallic nanoparticle is silver nanoparticles, as its diversified applications and at the same time its particle size. since which is having a very small particle size which finds applications in many fields. How these metallic nanoparticles are synthesized, there are widely three kind of approaches. One is physical approaches, then chemical approaches, and then the biological approaches. So in the physical approaches, mainly we will be using the green synthesis. So green synthesis, where we will be adopting either the evaporation condensation method or laser ablation methods. In the evaporation condensation method, we will be using the high temperature furnaces, and which will be maintain the temperature between 700 to 900 degrees Celsius, which will be that the target molecules will be evaporated and which will be converted into gases or vapors, and then which is allowed to condense. So in that way, these type of nanoparticles are synthesized by evaporation and condensation methods. Then the other type of method, and which is one of the most common method, is laser ablation. So in the laser ablation method, mostly we will be using Nd:Arc lasers. So Nd:Arc lasers is the commonly used the lasers which is used to that is which is applied to prepare the nanoparticles. In the laser ablation, we will be applying the lasers, and which will be applied to the target molecules, that is the bulk molecules, and which will be evaporated, and while condensation, which will be converted into its particles, which is having the size of nanoparticles, that is which is in the order of 10 to the power -9 nanometer. So in addition to that, we have few more physical approaches, and these are the two majorly used physical approaches. And then we have a very big list of chemical approaches, right from the reduction methods. And mostly to prepare the silver nanoparticles, in the reduction methods, the substrates used are trisodium citrate or sodium borohydrate. And the other methods are UV irradiation, gamma irradiation, microwave irradiation, then sonochemical reduction, sonoelectrochemical methods, electrochemical methods, polysaccharide methods, and tolerance methods. So if I explain each and every method in detail, it will take much time. So I'll give some references at last. You can explore later, through which you can able to understand exactly how to apply these methods and what are the steps followed, and each and every minute steps which is explained in the already reported literature, what we have followed. If time permits, at last I'll explain at least one method in detail, right from the quantity of the substrates we have taken, the target molecules we have applied, and what is the particle size we obtained. So in that way, if time permits, and at last I will explain you. Before that, I will give the wide outline about the nanomaterials and its synthesis. And the third type of synthesis approach is the biological approach. So where nanoparticles, if we talk about nanoparticles, that two metallic nanoparticles, we have to concentrate more on silver nanoparticles. And the silver, as I told already, silver nanoparticles have wide applications. The silver nanoparticles, either with the help of the bacteria or with the help of fungi or by the application of plants, which will be synthesized. So that's what we can say, it's a green synthesis. So nowadays, most of the silver nanoparticles are obtained from the biological approaches. I'll explain, I'll show some of the evidences that we have already prepared. See, actually, this is one of the silver nanoparticle we have prepared, and at last we published and we have filed the patents also. So that is that's what by this stage better I can explain how to approach or how to choose the topics. Suppose if we intended to do the do your research in the nanomaterials, nanotechnology side, so where you may have different ideas, that is in which part of nanotechnology you intended to do. Accordingly, you can give the keywords, and based on that, you can do both the kind of that is a literature review, that is a non-patent literature and patent literature. So generally people will be following the non-patent kind of literature survey before doing before starting their PhD. But my advice and the opinion is better you can do the patent literature also. So where you can able to find what is the latest technology they have used, and what are all the latest fields, and what extent people have reported in that particular area. From that you can have a start for your research work. So in that way I can suggest you. So whenever you that is generally that is paper writing or journal publications, you are all aware that so how to draft all those things. But in the patents, you will be drafting how you are drafting your technical papers to report to the journals. In that way you will be drafting, and at last you will be giving the claims also. For the claims only you will be giving the final patent grant. Say for example, why I am insisting, and I have showed this claim page, and this is one of the claim page of our research work we have submitted in the patent offices, the silver nanoparticles. See, in the claims we have to explain each and every minute steps and the things which is involved. So from that, if you do the that is a literature survey from the patent literature or patent office site, you can able to understand each and everything. And this much minute details you may not get in the journals. Say for example, from this claim you can understand always the first claim will be the independent claim. See, from this claim we can understand that it's reported the silver nanoparticles, that too cannabis sativa leaf extract, and most of the silver particles are nowadays obtained from the green approaches by using the biological materials, and that too mostly from the plant extracts. So, okay, and the another kind of leaf extract also we have reported, and these silver particles, which is what we have claimed in the independent claim. So, wherein these silver nanoparticles having antibacterial activity against both the gram-positive and gram-negative bacteria. And how to do these testing, that we have given in the detailed description of the invention. And we have tested for the varied concentrations, the different concentrations, right from the dilute concentration to concentrated concentrations. And in the third claim, we have claimed that the method for green synthesized silver nanoparticles comprising the following steps. So here in the patent reports, literature, each and everything it is explained, it is very easy to follow. And even if you don't have any idea regarding the particular field, you can able to get more knowledge from these sites. And how to get these papers, you can go to patent office site. So for that you have to go to the patent office site. So where you have to type ipindia.gov.in, ipindia.gov.in. So you have to type. So where you can get all the papers, patent literature in which you are going to pursue your research. So you have to go to the public search, and then patents. Then you are going to the external page, do the patent search, and here so many fields will be asking. So in that, you can give your keywords. Say, for example, in the abstract, I am giving silver nanoparticles. Silver nanoparticles. And at last, it will be asking the captcha.
Ma'am, sorry to interrupt you. The screen is not moving. It is standing in biological approaches.
Oh, it is not shared.
Yes, ma'am. It is standing at biological approaches. That slide has not been moved.
Oh, okay. Actually, I have, but already it is shared only.
Yeah, it's shared, ma'am, but the screen, it is not moving to the next slide. It is in biological approaches.
Now, ma'am, now it is okay.
No, till now you are not able to see, ma'am.
Once again, share your screen, ma'am.
Ma'am, PPT not showing, madam.
Oh, not moving, sir.
Yes, madam, not moving, madam.
It's okay. I'll once again stop and again I'll.
Yes, madam. Yes, madam.
Start, sir.
Again, share the PPT, madam.
Yeah, sure.
Thank you, ma'am.
Now it's okay, sir. Is it okay? Is it visible?
Yes, ma'am, it's visible.
Yes, madam.
Yeah. So you have to search with the ipindia.gov.in, wherein you have to go for status, and then you are moving to the external page where you have to go for patent search, and then you have to put the keywords either under abstract or under the title. See here, I have typed silver nanoparticles and I have given the captcha. And if I give the search, I am getting this page. See, in this page, this many, that is outcomes I am getting. EDCE. Yeah, since I have given 3 words, silver nanoparticles, all the 3 words it is taken into account, and based on that we are getting the list of titles. So where you have to explore, otherwise you can type only one word. Then otherwise if you give the combination of words and which will be useful to find out, and from which you can extract or eliminate the things, and whatever the patents you want, you can go into it. Say for example, this patent explains the green synthesis of silver nanoparticles using cannabis. So was what I told us, almost the similar type of patent. It is reported already, and from which we can obtain all the details. So, okay. So in the view documents, so whatever the specifications they have submitted, all those details we will be getting, and at last we will be having the claims. From the claims we can understand what they are trying to explain. So okay, otherwise the detailed methods which is explained in the paper. So okay, so if you want to get more details exactly what is the procedure followed, that you have to get it from the detailed description of the inventions. And finally we will be getting the claims page, and at last for the claims only you will be given the patent grant. So in this way, whatever may be the field, so not only the nanotechnology, in that way you can put your keywords and you can get the search, and based on that you can find out. So from this you can understand how the people are doing research in this area and at what extent they have done. Similarly, you have to explore all the nanoparticles so that you can get a collective idea and you can come to the conclusion that what will be your proposed research work, and you can sit with your guide and you can carry on accordingly. So this is what I can suggest. And similarly, we have many papers related to this silver nanoparticles. Say for example, in the one of the reported silver nanoparticles, this is what the scheme followed. So that is from the plant extracts, and which is dried in the shade and then crushed into powders and then boiled at 70 degrees Celsius. That is the synthesis of silver nanoparticles is one of the very simplest methods. But how to arrive the novelty or the inventiveness in your research work? So since it is very simple, so you have to find out the source of the plant. And how to find out the source of the plant? That from the literature report, from which field of applications you are trying to work with. So accordingly, you have to do the literature survey, and accordingly you have to choose the plant extracts, and you have to try to explore whether you can able to synthesize the nanoparticles. So whether it is silver nanoparticles or the other kind of nanoparticles. So you can explore the different kind of nanoparticles having applications in the different fields. For which application you wanted to work, you are intended to work, accordingly you have to choose the plant leaves and you have to follow the procedure. And this is what the almost the same procedure, that is the outline of the procedure is same. The only thing is the application of that is the temperature you have applied, and what is the agents you are using for the synthesis of silver nanoparticles, and what is the method you are going to use. Accordingly you can vary the thing, and based on that you will be getting the particle size. And by varying these parameters also you can try to vary the particle size. And in this method, and the next to that, the filtrate is filtered and the extract is taken, and in which the silver nitrate is added, and we are doing the microwave irradiation process, and then the silver nanoparticles is obtained. And this is one of the stock solution we can have. That's what I told. The silver nanoparticles is having one of the peculiar property that the silver size is very less. It can able to penetrate or diffuse into the biological things very easily, and hence which finds many biological applications. And from which we can understand that what will be the wavelength range of the synthesized nanoparticles. So almost most of the synthesized nanoparticles are formed by this region, 446. Similarly, so this is another kind of synthesis of nanoparticles by green approaches. And this is what the plant extract they have taken. And then these are the steps they have followed. As I told, always the first claim will be the independent claim, and based on the claim, whatever the outer outline or the various wide steps we have mentioned in the independent claim, so that claim will be explained in depth in the following claim. So that's what, so that is the correct way of writing the claim is next to the independent claim. The dependent claims, see from the indentation you can understand. So they have given one tab. It is understood that these claims are followed by the first claim. So here, as per this claims, the second, third, fourth, fifth, and all these claims are dependent claims of the first claim. Say for example, in the first claim we have given that is hardening, and say for example, if you choose hardening, this is one of the most common method. In the hardening, how we are doing this process, if you explain in detail in the following claims, that is the dependent claims. See, from the claims you can understand very well, that is how to follow exactly, how to measure, and what are the methods they have used, and how they have applied and what are the process, what is the exact process, all those things you can able to understand.
Ma'am,
Yeah, sir.
please complete for 1 or 2 minutes.
Okay, I'll complete it, sir. And from this experimental setup, we can understand the electrochemical method of synthesis of silver nanoparticles. So almost the people who are intended to do your research in this field, you can able to understand what is electrochemical reaction. In the same way, you can understand this method also. And by using these methods, you are trying to get the particle size of nanomaterials. And this is what the silver nanoparticles obtain. From the color itself, we can understand. And in most of the silver nanoparticles, we are getting the color like this. And this is the various layers, that is the cross-sectional view, the various layers which is involved in the silver nanoparticle solutions. And these are all some of the applications. So that's what, as I told, if we do the green approaches, definitely or very well we can use the nanoparticles for the biological applications. And these are all some of the practical applications we can able to see or we are evidenced. And this is one of the disinfectants where the silver nanoparticles are applied. And these are all some applications.
PPT not moving, madam.
Not moving.
Yes, madam. Actually, it is showing dynamic status e-register pattern. That's
yeah. Since I am changing now, sir, changing the that is sides. I think
sides not moving, madam. Slide not moving.
I think now it's okay, sir.
Yes, madam. Yes, madam. Okay.
Yeah, these are all some of the applications, as I told.
Okay.
These are all practical applications. And this disinfectants where the silver nanoparticles are involved. And these are the other applications. Yeah, if we explain each and every applications, it will take another 1 hour. So better just I'm giving the various fields, and you can have a detailed study later. And at the same time, how the silver nanoparticles is advantageous, equally we have disadvantages too. The silver nanoparticles, if we are exposed prolonged with the colloidal silver nanoparticles, the color of the skin will be changed into blue-gray appearance, especially on the faces, and the symptom is called argyria. See, so this is what the people who are affected by this kind of disease. So we have to use this, that is silver nanoparticles.
Okay, madam. Thank you, madam. It's a very nice presentation, madam.
Yeah, thank you. Thank you so much, sir.
Okay, the audience.
Within the time.
Yes, madam. Completed, madam.
Any
from audience, any questions from audience? Hello? Any questions from audience? Okay. If you have any doubt, please send a mail to ma'am. Ma'am is also very near in Chennai, Sri Sai Ram Engineering College.
Yeah, you given my mail ID and even phone number.
Yes, madam. Please give it to the chat box, madam. It is very helpful.
Okay, so if you have any clarifications,
yes, madam.
Or if you are willing to do collaborative work,
yes, madam. Yes, madam. Yes, madam.
Thank you.
Participants, already I posted a feedback link for note session. Already I posted in chat box. So please check it. Also track to the same last 2 days, same track to link also, Gmeet link also posted in the same text box. Please join track 2. Track 2 people, please go to the track 2 session. Track 2 madam also there. Are you there, madam? Geeta madam? Okay.
Okay, sir. I am leaving.
Yes,
thank
madam.
you.
Yes.
Thank you so much.
Okay, thank you, madam.
The audience for your patience listening. Thank you.
Thank you, madam. Thank you. Okay, track 1 people keep the same session only. This is also track 1. Sir, sir?
Yes, sir. Yes, sir.
Sir, please take over this session. Shall I leave, sir? Shall I
Yeah,
leave, sir?
please, sir. Please.
Okay, thank you, sir.
Thank you. Thank you. Sir, allow all the earlier people, earlier session people. Good morning and welcome to